Imagine a lens 3,000 years old, possibly the very first telescope in human history, or a drinking cup that changes color through nanotechnology, 1,600 years before humanity even discovered that nanoparticles existed. And what about a dentist who, 9,000 years ago, drilled cavities with a flint bit, no anesthesia, no painkillers, yet worked with a precision of 0.5 millimeter? Today we're examining 6 ancient technologies that science has officially confirmed are real, yet still cannot fully reproduce. And the most astonishing discovery of all is saved for the very end. We tend to look down on the people of the past, primitive we assume, while we are advanced. We have smartphones, orbiting satellites, artificial intelligence. They had sticks and stones. It's a comforting story. The trouble is, it falls apart every time something is pulled from the ground that by all rights shouldn't exist. A find that refuses to fit the accepted timeline. A device we cannot recreate, not because we don't want to, but because we genuinely don't understand how it was made. Here are 6 such discoveries, and each one is a direct blow to our arrogance. Coming in at number 6 on our list, Iraq, the 7th century BC. The residence of an Assyrian king. The year is 1850. British antiquarian Austen Henry Layard is excavating the palace complex at Nimrud, capital of the Assyrian Empire, in what is now Iraq. Among the countless artifacts he uncovers is one modest, unassuming object, a slightly elongated piece of rock crystal, roughly 7.5 centimeters long. Layard packs it away with the rest of his finds and ships it off to the British Museum. There the crystal sits for more than a century, drawing almost no attention at all. Now consider this carefully. What we're looking at is a flawlessly polished optical lens, ground from natural quartz. Its focal length is 12 centimeters with 3 times magnification. On its surface you can make out 12 tiny cavities, trapped oil bubbles, sealed inside the mineral as it formed. The lens was shaped on a lapidary wheel, a device used for grinding stone. Scientists date the artifact to somewhere between 750 and 710 BC, making it nearly 3,000 years old. So why would the Assyrians need a lens? The British Museum's official description is cautious, an object of fairly limited practical use. But Italian Orientalist Giovanni Pettinato of the University of Rome strongly disagrees. He points to something remarkable. The Assyrians appear to have known about the rings of Saturn. In surviving reliefs, the planet is depicted as a deity encircled by a serpent ring. And yet the rings of Saturn are physically impossible to see with the naked eye. That much is well established. But pair the Nimrud lens with a second lens just like it, and the magnification jumps high enough for genuine astronomical observation. Today, several hundred similar ancient lenses have turned up worldwide, from Egypt's 5th dynasty to Minoan Crete. But none has sparked as much scientific debate as the one from Nimrud. Layard himself once proposed that Assyrian craftsmen used the lens to engrave miniature details onto seals. Details so fine they could only be seen through magnification. But that explanation raises an obvious counter-question. If these craftsmen already had lenses for delicate jewelry work, what stopped them from eventually turning that same lens toward the sky? The Nimrud lens still sits in a display case at the British Museum today, 3,000 years of history, and the argument still hasn't gone away. A simple curiosity, or a fragment of the world's first telescope, built 23 centuries before Galileo? Coming in at number 5, an object that looks like an ordinary glass cup until you change the lighting. Rome, the 1st century AD. The Lycurgus cup, the only fully intact Roman vessel made of dichroic glass ever found. It stands 16.5 centimeters tall. Carved into its surface in striking relief is the mythical king Lycurgus, entangled in vines, suffering punishment at the hands of the god Dionysus. The work is delicate and intricate, made using a technique known as cage cup carving, in which the outer decorative layer is partially separated from the vessel's inner surface. Very few cups like it have survived, and none can compare to this one. Picture this. You're holding the cup in ordinary daylight. It's green, dark, with a jade-like sheen. Now place a light source behind it, a candle, a lamp. Instantly, the cup turns red. Not pink, not orange, a deep, saturated blood red. Move the light away and the cup turns green again. Two completely different colors from the same object. No paint, no coating on the surface. The secret is hidden inside the glass itself. In the 1990s, when scientists finally examined the glass's structure under an electron microscope, they were stunned. For an artifact 16 centuries old. Inside, they found nanoparticles of gold and silver, ground down to just 50 nanometers, 2,000 times thinner than a human hair, and 1,000 times smaller than a grain of salt. These particles are distributed evenly throughout the entire thickness of the glass. It's this precise distribution that bends light in such an unusual way, producing the dichroic effect. Nanotechnology, in the 1st century AD. We only discovered the concept of nanoparticles in the 1970s. The Romans beat us to it by 1,600 years. Researchers at the University of Illinois have tried to recreate the effect of the Lycurgus cup using modern technology. They've gotten results, but not the same results. Neither the quality nor the precision of particle distribution comes close to matching the original. A lucky accident can't entirely be ruled out. But Roman glassmaking operated on an industrial scale, thousands of workshops, generations of accumulated expertise. What if this isn't an accident at all, but a fully lost technology we simply haven't figured out how to recover? The cup keeps its secret. All it does is keep changing color. Coming in at number 4, instruments so prized for their sound that the world is willing to pay $16 million for them. Cremona, Italy. Between 1680 and 1720, master craftsman Antonio Stradivari built roughly 1,100 violins, violas, and cellos. About 650 of them survive today. Each one has become something close to a sacred object. In 2011, a violin known as the Lady Blunt sold for $15.9 million, the most expensive musical instrument ever auctioned. Pick up a Stradivarius, and on the outside it looks completely ordinary. Wood, varnish, 4 strings, nothing remarkable at first glance. But the moment a musician draws a bow across the strings, something happens that can't be put into words, and can't be reproduced by any other means. The tone, the depth, the way the sound fills a concert hall. A Stradivarius projects through a room like no modern instrument can. So what's the explanation? There are dozens of theories. One of the most widely discussed ties the phenomenon to the Little Ice Age. Between 1645 and 1715, during a period known as the Maunder Minimum, temperatures across Europe dropped noticeably. Trees grew more slowly, and their growth rings became denser, packed tightly together. The result was wood with an unusual density and elasticity. Stradivari worked with exactly this kind of timber, spruce and maple from the alpine forests. Wood that, in this particular form, no longer exists today. There's another theory too, chemical treatment of the wood. In 2021, researchers at the University of Texas found traces of mineral salts in the wood of Stradivari's violins. Boron, aluminum, sodium, and calcium, substances that don't naturally occur in untreated timber. It seems the craftsman soaked his wood in mineral solutions before final assembly. In 2023, another research team in Taiwan identified traces of borax and zinc compounds as well. The chemical treatment theory gained further support, but no one has managed to recreate the exact formula. Then there's the varnish, a mystery of its own. It's been analyzed hundreds of times across 3 centuries. Every new lab produces a different answer, and none of them agree. Some have found traces of propolis, others, volcanic ash. Others still, resins that no longer exist in nature today. The recipe for Stradivari's varnish remains one of the most sought-after lost formulas in the history of craftsmanship. Over the past 3 centuries, dozens of violin makers have tried to reproduce Stradivari's instruments exactly. They've copied the shape, hand-picked the wood, imitated the varnish. The results are good, sometimes excellent, violins. But they're not real Stradivari's. In 2014, a blind test held in Paris found that most soloists actually preferred the new violins over the old ones. But when the same kind of test was repeated in 2017, this time in a full concert hall, the antique instruments won. Maybe Stradivari's secret isn't in the violin at all, but in the acoustic space where it's played, though that too is just one theory among many. Antonio Stradivari died in 1737, and his secret was buried right along with him. Taking third place on our list, a discovery 4,500 years older than the Egyptian pyramids. Mehrgarh, Baluchistan province in what is now Pakistan. A Neolithic settlement 9,000 years old, one of the oldest in all of South Asia. In 2006, an Italian-French research team published findings in the journal Nature that genuinely stunned the world of dentistry. The discovery involved 11 molars belonging to 9 adults who lived between 7,500 and 9,000 years ago. Each tooth had a neatly drilled cone-shaped hole between 1 and 3.5 millimeters in diameter and up to 3.5 millimeters deep. The walls of these holes were smooth, marked with the kind of concentric rings characteristic of rotary drilling. These weren't signs of natural wear, not a disease, not a ritual practice. This was an actual dental procedure. Picture the scene. You're in a Neolithic village 9,000 years ago and you have a toothache. Someone approaches you holding a flint drill, a thin stone shaft fixed into a wooden handle, spun by a bow drill mechanism. With no anesthesia, no antiseptic of any kind, they begin drilling into your tooth with a precision of 0.5 millimeter. Experiments have confirmed that a flint drill like this can cut through enamel in about a minute. None of the 11 holes examined were found in a front tooth. All of them were in molars. That points to a strictly functional purpose, not a decorative one. People were having their decayed teeth drilled to remove the diseased tissue. 4,500 years before the first Egyptian physician, 6,000 years before Hippocrates, 8,500 years before the invention of the dental drill. So who taught these people this skill? How did they know to drill into a diseased tooth in the first place? Did they use any kind of filling material, or were the holes simply left open? Some of these questions already have answers. Traces of beeswax have been found in several of the teeth, apparently used as a filling material. On the rest, science still has nothing to say. 9,000 years ago, in a settlement with no writing and no metalworking, there was already, in every meaningful sense, a professional dentist. Mainstream science confirms the fact, but still can't explain it. Taking silver in second place, an object that has stood out in the open for 1,600 years and simply refuses to rust. New Delhi, India. The Qutb Minar complex. In the courtyard of the Quwwat-ul-Islam Mosque, surrounded by medieval arches and minarets, stands an iron pillar 7 meters and 21 centimeters tall. Its base measures 41 centimeters across, and it weighs roughly 6 tons. An inscription on the pillar honors a ruler named Chandragupta Vikramaditya of the Gupta dynasty. Scholars date the structure to the early 5th century AD, meaning it has spent 1,600 years standing continuously in the open air. Consider this. Delhi has a genuinely brutal climate. A monsoon season with crushing humidity, summer heat climbing past 50 degrees Celsius, and thick winter fog. Any ordinary piece of iron in those conditions would be rusted through within a few months. Not this pillar. 16 centuries and its surface shows barely a trace of discoloration. No corrosion, no structural damage. According to historical accounts, in the 16th century someone even fired a cannonball at it, and it did the pillar no harm at all. Scientists searched for an explanation for 91 years, from 1912, when British chemists first took samples of the material, all the way to 2003, when a team led by Professor R. Balasubramaniam of the Indian Institute of Technology, Kanpur, published their findings in the journal Current Science. It turned out the pillar was forged from wrought iron containing about 1% phosphorus. By comparison, modern iron contains less than 1/20th of 1%, 20 times less. Ancient metalworkers smelted the iron ore using charcoal in a single processing stage, with no blast furnace, no added lime, and no separation of slag from the metal. As a result, the phosphorus stayed locked inside the metal itself. Smiths then hammered the rough iron repeatedly, gradually driving the phosphorus from deep within the material out toward its surface. Within the first 3 years after the pillar was erected, a paper-thin protective layer of misohyte formed on its surface, an amorphous iron hydroxide just half a millimeter thick, around 20 microns, roughly a fifth the thickness of a human hair. This misohyte layer acts like a self-healing shield, sealing the metal off from both moisture and oxygen. Modern science can describe this process in exhaustive chemical detail, but still can't recreate the ancient forging technique behind it. Today we know how to make stainless steel, but we do it in a completely different way, using chromium, nickel, molybdenum. Ancient Indian blacksmiths achieved the exact same result with nothing more than a hammer, charcoal, and phosphorus. No laboratories, no chemical formulas, no knowledge of the periodic table. Balasubramaniam called the pillar a living testament to the supreme skill of ancient Indian metallurgists. 6 tons of iron standing through 1,600 years of monsoon rains without a single gram of rust. It isn't magic, but it's also a technology modern science still can't reproduce. And finally, the undisputed winner of our countdown, number 1. A stone that served the Vikings as a kind of ancient GPS, the North Atlantic, the 10th century. Viking sailors are crossing open ocean from Scandinavia to Iceland to Greenland to the coast of Newfoundland, covering thousands of kilometers of open water. The compass hasn't reached Europe yet. It won't arrive from China until later that same century. There are no maps. The sextant is still 700 years away from being invented. Icelandic sagas, including the saga of Raudulfur and the saga of Saint Olaf, describe a mysterious object called a sunstone. When thick clouds covered the sky and the sun vanished from view, the navigator would take out this stone, hold it up toward the sky, and the stone would reveal the sun's exact position. It sounds like pure legend, and for centuries that's exactly how it was treated. But in 2011, on the floor of the English Channel, among the wreckage of an English ship called the Alderney, which sank in 1592, a piece of crystal was discovered. It turned out to be Iceland's spar, a form of calcite with a unique optical property, birefringence, or double refraction. As light passes through a crystal like this, it splits into 2 separate beams. Slowly rotate the stone while watching the 2 images of the same point, and there's a position where both images become equally bright. That exact position points directly toward the source of polarized light, toward the sun itself, even when it's completely hidden behind clouds. Picture the scene. A navigator aboard a longship somewhere on a gray, overcast northern sea. The sky is a solid sheet of cloud. The horizon dissolves into the water. No landmarks, no stars, no visible sun anywhere. The navigator pulls a clear, fist-sized piece of crystal from a pouch, lifts it to his eyes, and slowly begins to turn it. At some point, the 2 blurred images inside the crystal align and match in brightness. He lowers the stone, turns the ship toward the direction he's found, and tells the helmsman which course to hold. In 2013, physicists at the University of Rennes in France ran an experiment. A group of volunteers was given pieces of Iceland's spar and asked to locate the sun under heavy cloud cover. The result: accuracy within 1 degree. For comparison, a magnetic compass at high latitudes can be off by as much as 5 degrees due to magnetic declination. An ordinary stone, it turns out, was more accurate than a compass. In 2018, Hungarian physicists built a computer simulation showing that navigation using a sunstone would have produced a successful voyage from Norway to Greenland more than 90% of the time, even under fully overcast skies. 90% success with nothing more than a piece of mineral. The Vikings knew nothing about the physics of light polarization. They had no concept of optics. They'd never heard the word calcite, but they knew something just as valuable. Look through this particular stone at a gray sky and it will show you exactly where the sun is hiding. That knowledge alone was enough to cross the Atlantic Ocean 500 years before Columbus, without a single instrument we'd recognize today as navigational equipment. Just a piece of stone, and the understanding of how to use it, an understanding that science itself wouldn't catch up to until the 21st century. The Nimrud lens, the Lycurgus cup, Stradivari's violins, the dental fillings of Mehrgar, the iron pillar of Delhi, the Vikings' sunstone. 6 technologies, 6 different eras of history, and all of them point to the same uncomfortable truth. The people of the ancient world possessed knowledge that we, today, simply don't have. Not because they were smarter than we are, but because they faced problems that simply don't exist for us anymore. How do you preserve a loved one's body without formaldehyde? How do you cross an ocean without a compass? How do you forge iron that won't corrode without chromium? They found their own answers, and those answers worked. Then the craftsmen died, the empires collapsed, the cities sank beneath the waves, and the answers they'd found disappeared right along with them. We live in an age where almost any piece of information can be found online in a matter of seconds. It feels like losing a technology should be impossible now, like progress is a one-way road leading only forward, only upward. And yet the formula for Stradivari's varnish was never preserved, even though the man worked just 3 centuries ago in the age of the printing press and university education. We know the exact chemical makeup of the Nimrud crystal, but the process used to shape it was lost 3,000 years ago. The protective meso-white layer on the Delhi pillar has been studied down to the molecule, yet we still can't replicate the forging method of 5th century blacksmiths. The Romans, by accident or by design, created genuine nanoparticles and then lost the very technology that made them possible. A Neolithic dentist in Mehrgar drilled diseased teeth with a precision that would impress a modern dental professional, and left behind not a single record of who taught him or how. Maybe 1,000 years from now, someone will look at our smartphones with the same bewilderment we feel looking at the Lycurgus cup and say, they knew how to build things like this, and they still vanished without a trace. Which of these 6 technologies surprised you the most? Let us know in the comments. I'd genuinely love to hear which one you're hearing about for the very first time. Hit like if you learned something new today. It's the best way to tell the algorithm that more videos like this one are worth making. And subscribe to the channel so you don't miss the next journey into mysteries that science has documented, but still hasn't fully solved. Even stranger stories are still ahead.